Good morning. This is Tim Stewart. I am president at Visual Decisions. We're here today to talk about how to use the Industrial Internet of Things, or I-IoT, and BI together to drive performance improvements. At Visual Decisions, we've been in the business of utilizing information from the shop floor to improve operations since about 2002. We help our customers combine the smart factory with the lean factory to drive improvements to cost, throughput, and quality. With that, let's go ahead and get started. If you have questions, please enter them into the Q&A or the chat, and I will get to them at the end of the presentation. So what do I mean when I talk about the Industrial Internet of Things and business intelligence? So the Industrial Internet of Things, there's broad concept on the concept. How it's implemented in different platforms varies pretty widely. The one that I use most frequently is from PTC. It's called ThingWorx, and it can provide a wide variety of different capabilities to the shop floor. And so, just looking at some of these with OEE and maintenance with predictive and prescriptive analytics and condition-based monitoring, being able to deliver work instructions out to the shop floor and so forth. There's a number of different capabilities that I-IoT provides. We'll get more into the definition of it in a couple slides. As far as business intelligence goes, I'm really talking about the modern platforms such as Power BI, Tableau, Qlik, etc., that provide a variety of different capabilities for taking information from different systems, kind of combining that together and presenting information in a number of different, very flexible formats. And so you can see some of the different capabilities here in terms of dashboarding and some data science capabilities and data visualization and so forth. And these tools are fantastic for very quickly bringing information from those disparate sources, combining them together, and presenting everything in a very rich context. So what are the primary strengths of each system? And there's actually a number of similarities, but the systems are fundamentally different in purpose. So for business intelligence, it's really meant to blend data together from different systems. It doesn't really generate any data of its own, but it takes the data from all of those different places and it acts as a point of consumption for that data. It's really built as a hub for analysis. And so can, again, act as that central place where people can go to see information from any different system that you have that collects data from your organization. And then it easily coexists with other systems. Again, since it doesn't generate the information on its own, it's dependent or reliant upon those other systems to give it the information that it can then display to the users. These systems are nearly infinitely flexible in terms of how to present information to the user, how to create different workflows for analysis, for reporting, etc., and can easily be used to build guided analysis. And I'll talk more about what I mean with that in a little bit. But essentially, it's creating a workflow for your people so that they're not doing all kind of ad hoc analysis where it's reliant upon them to be able to figure out what's important for them to go look at. These systems are very good for historical analysis. They can pull information for the previous 30 days, 90 days, year, 2 years, etc., and be able to present that information so that you can see the trending, you can see how things are changing and adapting within the organization. And then they can also be integrated, or some have the built-in capabilities for artificial intelligence, machine learning, and so forth, so that you can add that type of intelligent capability to your analytics. Now, the Industrial Internet of Things, you'll see that the capabilities there are phrased pretty similarly, but it's built to gather data. So as opposed to being that place where you send data for analysis, the IoT is built to actually be a point of connectivity for the devices within your operations. And so it's really meant as a hub for the shop floor where it can pull data from different systems, yes, but also from the machines themselves, whether that's industrial lathe or CNC machine, or something like a pair of connected calipers that you're using for measurements and so forth. And then it can push this information to a variety of different systems. And so it can store the information directly to a database, but it can also route that information to different systems within your business, so that this is truly a hub for your shop floor data, where it can not only collect information from different places and connect that information together to create a richer context, but it can then send that information to a variety of different places so that it can act as that traffic cop for the shop floor data. It very easily coexists with other systems. So even if you have something like a manufacturing execution system or MES in place, there's still a role for this IoT system to connect to things that an MES system doesn't really care about. And it's also nearly infinitely flexible in terms of being able to provide connection to just about anything that's out there. That's the whole idea of Internet of Things. But then also in terms of the displays that it can provide, is really based more on the real-time data and the real-time information coming in from the systems and so forth, maybe with some history. It's not really meant for historical analysis, though. It's really meant for the information that's happening today and how that compares to the history and so forth. And then it's very good for building visual controls on your shop floor. So if you have instances of the visual factory that you're putting in place, an IoT system is a great solution for being able to put those controls in place in a digital way, so that they can be live and continuously updated without the waste of people manually making those changes. As I said, it's very good for near real-time to real-time analysis. And these can also be integrated with artificial intelligence and machine learning, so that you can deploy those at the edge and have that near real-time connection and feed into the model, so that you can trap exceptions and utilize those predictive capabilities much closer to the actual machines, so that the timing of that can be much faster, and you can act upon those machine learning and predictive capabilities in a much more smooth fashion. So when I look at frameworks for analyzing situational problem solving scenarios and so forth, at the top here, I have the problem solving axis, and whether that's done kind of inline, in real time, at the line, during the shift and so forth. Offline, maybe same worker or the supervisor, maybe an engineer for the line that is doing this work still within that same day. Or whether it's offline by engineering or quality or continuous improvement, not just away from the line, but really looking at the greater trends. What are the overall biggest problems that we have with this workstation and so forth, or the flow of material within the factory. So maybe also looking at a bigger picture than what you're doing at the machine itself. And then over on the left side, we have different actions that we're taking, whether that's monitoring and detecting, understanding and diagnosing issues, deciding what to do, and then taking the action upon it. And I've color coded this so that what happens within the IoT system is in blue, what happens within the BI system, or best done within the BI system, is in orange. And you can see kind of that split where when you're doing things offline, looking at that historical data, looking at that bigger picture, looking at a broader context maybe of pulling information from warranty systems and combining that with what you have in engineering and so on. Those are things that are more easily done in that BI system, whereas the things that are being done in context at the machine or near the machine are things that are very more easily done within that IoT system that is connected to that process itself. So when we look at a simple view of a typical framework here, as we're pulling information from the shop floor, whether that's from sensors or actuators or a PLC connected to a SCADA system, or just connected to something like Kepware, or whether we're pulling the information into an MES first and then blending that with some of this additional information. You'll pass through kind of an IoT gateway. Again, could be something like Kepware, could be Azure IoT. And then you also have deployment at the edge for some of that computing and analytics that you might put in place for those predictive capabilities. But this is happening at this edge layer, and this is largely the domain of that IoT system. Now, the information from there is going to be passed into a database, passed to other systems and so forth. And you may have more advanced analytics that you're putting in place within those destinations. And then this is being delivered in a couple of different ways. One way it can be delivered is through real-time alerts, for critical incidents, things that need immediate attention. That can be done through mobile or other devices. And then you also have those workflows that are for data analysis, and how do you build up those continuous improvement actions for addressing those long-term trends and losses and so forth. And those are things that are done typically more at a computer through a web application where you have access to much more detail at one time and so forth. These workflows, there is overlap there between what's typically done within the IoT system and what's done within BI. Typically, most of those real-time alerts are going to come from the IoT system. The action workflows are mostly going to be done from the business intelligence system, but there's some overlap there based on where it makes sense, what the particular workflow is, and so forth. So whether you're looking at things within the IoT system or within the BI system, you want to be able to create a complete profile of that information so that people that are looking at that have kind of a comprehensive information about the process in order to improve it. And so as you're looking at that IoT data coming from the machine or the sensors and so forth, you want to be able to blend that with higher level information about the work orders that's associated with the different parts or products, ingredients, et cetera. The work instructions, quality and test results, any maintenance work orders that may have happened during that process and so forth, bills of materials and how things stack up together and so forth, cost information, and be able to look at the entire context of what's happening on the shop floor so that you can really tell, am I winning or am I losing in this particular day? And if I look at where that information comes from, you have devices and sensors, out on the shop floor. You have plant and operations systems that you're pulling that information from, such as MES and so forth. Then you have higher level systems, supply chain, inventory systems, ERP, et cetera, that have critical information about the different work orders and product information and so forth that is critical in order to interpret this information. But then even outside of this, we have things that can provide an important context for the data that we're looking at. One example that I look at all the time is warranty information and customer service information, so that as I look at what's happening out in my warranty or my customer service, I can tie that back into what was happening on the shop floor when those products were produced. And then I can start to build a correlation between what happens on the shop floor for items that end up in warranty versus those that don't. And this helps me prevent future warranty issues from happening. Then if I look at the different types of metrics that I'm putting in place, whether that's through visual controls on the shop floor, or whether that's through looking at some of these longer term trends and so forth that I might be looking at business intelligence, there's a differentiate between performance metrics and diagnostic metrics. The performance metrics are typically those single number things like first pass yield or OEE or any number of different things. And they're very useful for being able to tell, again, am I winning or am I losing today? But if I can see that my first pass yield dropped from 98% to 93%, I know that I have a problem today, but I don't know why. And so being able to collect those diagnostic metrics as well is very important. And so being able to categorize for each piece that goes bad, or each time the machine goes down, understanding why it went down, what happened, is very important. So if I can categorize those different failure modes, and then go into levels of detail on that, ask why at least a couple of times, that really helps me tie that into proper corrective actions that I can guide the user to when those things occur. And so, as I look at how these things tie together, these diagnostic metrics are kind of that lowest level of information. And then these, kind of feed up, aggregate into performance metrics. And then those performance metrics tie into financial metrics. And this becomes very important at the plant manager level, at the corporate level, and so forth, because we have to understand, am I running the business in a profitable way? And so there's really a couple of different ways that you can compare, a quality event versus a downtime event versus a setup event, and so forth. And one way to do that is to kind of put everything in the dimension of time. And you can look at everything on a time-based way so that you can see kind of a common set or a common view of what are the biggest things that are impacting my operation. But you can also do it from a perspective of cost. And the cost helps you pull in things like material cost and everything else. And so whichever you choose, financial metrics or time metrics, or maybe both, you want to be able to provide that common analysis, that common language for understanding how to compare different issues that are happening and which are the biggest impacts to the operation. The next step here is that the performance metrics that you're collecting should align to the different processes that you have in place. So if you are doing total productive maintenance, or TPM, within your operations, you should collect information that supports metrics and visual controls out on the shop floor for things like autonomous maintenance or planned maintenance, et cetera, so that you can give your people the information that they need to run that TPM process as effectively as possible. If you're looking at things like lean manufacturing and so forth, being able to display that standard work and analyze that standard work for possible improvements, being able to have the 5 why information, being able to drill down into that causal data and being able to understand what are those root causes for the different things that are happening. So as you look at the information that you want to collect, how you want to display this and so forth, the different screens that you want to build up within your business intelligence system, really think through, how are your people going to consume this information, and what are the processes that they have in place today in order to understand the process and improve it. And usually that ties into these different things like Six Sigma, Lean, OEE analysis, TQM, TPM. And if you put things in place that support those processes with that raw data, you're going to have a much bigger impact, and it's going to fit within the culture of your organization much more easily. So then the next thing is looking at some of these different workflows. So I just talked about supporting workflows within things like TPM, but you also want to make sure that everything that you do is pointed towards taking action on the information that you're collecting. And so knowing what is happening and why it's happening is not enough. No value is gained if nothing changes. And the analogy that I use here all the time is a Fitbit. I've been wearing a Fitbit for almost 9 years now, and I've actually gained probably 20 pounds during that time. And it's not the Fitbit's fault. The Fitbit is a great example of an IoT device. It has advanced sensors. It collects that information at the raw data level, passes it up to a cloud-based application, applies machine learning to translate that raw sensor data into heartbeats and footsteps and everything else. It has wonderful, very friendly charts and graphs that I can look at on the web, on my phone, et cetera. It delivers alerts to me and so forth. But if I don't change my behaviors, if I don't fundamentally do something differently tomorrow than I do today, then I'm not going to lose the weight. And it's the same thing on the shop floor, where if I put all these things in place and I put these wonderful visual controls out there and so forth, if I don't have my people do something differently tomorrow than they do today, if I don't change the culture and the process of my organization, then I'm doing all this for naught. I'm not going to get the improvements that I'm looking for. So you have to think, how do I present this information to my people in a way that biases them towards action? And that's something that's very important. And part of how you do that is to provide guided analysis that leads them to what is the next step that's recommended. And so when you look at kind of most systems that are built for this purpose, like OEE systems and so forth, quality systems, they have reports in there that allow the user to kind of explore the data and so forth. It's built around trends and Pareto charts and pivot tables and things like that. Let the user slice and dice the data by different dimensions to perform manual analysis. But when you're building these things in these BI systems and the IoT systems, you can also structure these things so that you lead the user through a guided analysis. And you might create these around a single topic, such as setup analysis. And they may seek to answer particular questions, maybe constructed to illustrate data in a particular manner and so forth. And so if we look at some examples of this, you can build up a real-time value stream map. So value stream mapping is very, very helpful for analyzing the process, figuring out where your value add time, where your non-value add time is. If you build this into these systems, what you can do is you can actually set it up so that you show the user not only where that non-value add time is occurring and be able to do that automatically, but now you can prompt them to do something about that. How do you go about removing that non-value add time from the process? If I go through and look at setup analysis, we can collect information about the different tasks that are happening during setup, and we can do a SMED analysis to figure out what we can remove, what we can pre-stage, and all of those different things. But by putting that into the system and so forth, we can also help to guide the user through that analysis and lead them to what is that next step that they should take in order to reduce that setup time. And so there's a number of different examples of this guided analysis that you can put in place. And because of the flexibility of the IoT systems and the BI systems, you can support any and every single one of these. So now I'm going to look at some examples that we've built for customers, looking at this data analytics and business intelligence and so forth for information that we've collected from the shop floor. So as one example, looking at optimizing tool replacement. And the issue here is that if you leave the tooling on too long, the tooling eventually goes bad and you produce bad parts, and you look at maybe catastrophic failures on the machines and things like that. But then if you take it off too soon, you're not getting the full tool life, and you're spending too much money either on new tooling or refurbishing the existing tooling. And so looking at how to optimize that information, what we've done is working with customers, we connect directly to the machine PLC as well as other sensors to collect information such as vibration, noise, power consumption, et cetera. And then we pull that information through the ThingWorx system I talked about earlier, IoT, and built models based on the analytics to say, how much tool life do we think is remaining? What is our best guess at that? And then we can actually start to remove that tooling, not after a certain number of pieces, not when we've reached some time limit or piece threshold, et cetera, but really when we think that tool is about to fail and we have a high degree of confidence that that's about to happen. And then we can get that maximum tool life, but not risk the quality issues or the catastrophic failures on the machines. And so then this leads us to, how do we display that information to the user? It could be through ThingWorx on a computer or a tablet or mobile alerts. It could be through augmented reality, but you can also pipe that information through that business intelligence screens. This is one where we were working with a bakery, and we collected information from the shop floor. We displayed that in a number of different dashboards, but then as we looked at these overall levels of loss and so forth, the next question is, well, what is it that's causing that loss? And so we can see the trends and so forth, but then we also categorized each one of those different losses into, was it an equipment loss, a production loss, quality loss, et cetera. And then if we click on one of those bars, it drills down into that information so that we can see, equipment loss was our biggest loss. But then as we drill into that, we see that oven was the biggest category within equipment. And then we can start to see different trends for that. So because we have very little downtime most days, but then we have these big spikes, we can be certain that this is not a error proofing kind of a failure. It's not a poka-yoke solution that we need to put in place. This is something that's more of a periodic failure, something that we need to do preventive maintenance probably to address. And sure enough, this was something where oven shelves were flipping due to a broken pin. And we were able to kind of find the periodicity at which we needed to do preventive maintenance. And we were able to prevent the single biggest issue that happened for downtime in this plant by simply doing some extra PM on those pins to make sure that they didn't fatigue in the oven. This is kind of a higher level example of putting information into this overall management operating system that we created for actually a number of different customers, where we're pulling information from the shop floor. We're kind of bottling that information at the source, but then we're pulling that up into an overall dashboard for the company that everyone that logs into the system will see information that is relevant to them, the metrics that are important to their position, and then the data that's relevant to them as well. And so this is across safety, quality, delivery, cost, inventory, manpower, and environmental. And this was used by the chief operating officer on his weekly cadence calls with the plant managers. They used it in turn with their staff meetings and so forth, so that it could create that overall alignment and metrics from the top of the organization all the way down to the operators on the shop floor. In addition to just showing the raw data, everything is obviously color coded for winning or losing during that time period and so forth. And then you also have explanations for each miss. What was the explanation for that miss? And then what are the corrective actions that are being put in place? And then you can drill further into that to see who's responsible, when the date is, et cetera. Performance histogram is something where we're capturing the variability in the process itself. And so this is looking at the amount of processing time variation that we have as we're running different parts on the different lines and so forth. And this is very important for being able to schedule those parts and those lines effectively, because based on the product that we're running on, the line that we're running it on, et cetera, we need to know how much variability do we have. Does it have a single peak? Does it have multiple peaks? Should we forecast that at the mode, at the median, et cetera? And then how likely are we to have that process run long, run short, et cetera, and either cause starved or blocked processes within our operation. But then it also gives us a guide to say, how do we reduce that amount of variation that we have as we run that process, perhaps through standard work or other means. Then looking at other types of variation and eliminating that within the operation, we can certainly support X-bar and R charting and so forth, and be able to look at the overall variability of the process, and really dig from there into what are the sources of the variation, tie this into some of the detailed metrics that we're collecting about the machine temperature and other things like that that may be causal factors for that variation within that run chart. We can also present plant manager dashboards or other executive dashboards that look across the entire operation for how inventory is happening, inspection, defects and non-conforming materials, production information, et cetera, and be able to present that in a very tight format where they have drill down capabilities that they can click on literally anything on this screen to get more details about what happened at that particular time. This is another one where we were working with a power generation company looking at steam flow analysis. And the red line at the top here is kind of where the set point was for the machine. And then the dots are the actual measurements. And so you can see where they have what they call dents in performance. And then the bottom line down here is just showing where they are relative to the set point. Now, what gets really informational from here is when we plot that out in a scatter chart, we can see that those dents really only occur at particular set points. And so we were able to work with engineering there to determine why those particular set points led to the dents on a much more frequent basis than anything else. And then we also did correlation analysis for those different areas where we were having dents, what was happening at that time, so that we could correlate that where those dents were occurring with the different ways that we can analyze that information as well as control the process. And that led them to be able to remove those dents in many cases, or at least mitigate what was going on. And then we can even tie that into higher level business operations such as sourcing, procurement, supplier management, looking at different things like spend and category analytics, or sourcing events, contract analysis, performance analysis, et cetera. Some closing thoughts here. I'm running over by a couple minutes. When we look at a path to success for Industry 4.0, the first step is mapping out the vision. And for us, that is all about value. How is your company going to get value from these solutions? And for that, it's really tying that value into what are the root causes of the current performance, and then how do we actually address those root causes? And part of that can be looking at the systems that you have in place today. How can we pull that information in, make it much more accessible, and tie that into the process better so that your people can utilize that information more effectively? And one easy way to do that without doing any additional data collection is through these BI systems that can connect that information from different places and present that to users in that very flexible, workflow-driven way. And then using IoT, you can start to fill some of those different capability gaps. How do we achieve the art of the possible? How do we, get that really detailed information so that we can do that root cause analysis and so forth? And then integrating across processes, as I talked about earlier with warranty, being able to, pass that information across the organization and analyze it within context. And then, as I said with the Fitbit, you have to look at transforming the culture and the processes of your organization at every step along this way in order to take advantage of those new capabilities. Fundamentally, people have to do something differently tomorrow than they do today in order to achieve those benefits. Visual Decisions is here to help. We work across all of these different parts of the organization and all these different processes to provide support to you to drive these changes. And then I want to thank you. If you have questions or you just want to get started, please reach out to me at tim@visualdecisions.com. My phone number is right there. Please feel free to give me a call as well. Thank you very much. Bye-bye.